The model that we're going to rely upon for the rest of class, for the most part, is the normal model, the normal distribution. And this was something that we worked with quite a bit back in Chapter 3. We talked about the empirical rule. And it's the most common model for describing probabilities of continuous variables in introductory stats classes. It is a very close fit to many distributions. It's not going to be a perfect bell-shaped curve with perfect symmetry on the left and right, but it's going to be very close. For example, this histogram is displaying diastolic blood pressure. And this red line has been traced over the histogram, and we can see, well, it is fairly symmetric. It's unimodal with one peak in the middle. The left tail and the right tail are similar in length. But note that the bars don't fit perfectly underneath what's going on in this curve. We've got these two sticking out the top. We've got these gaps here. So the normal model is very close, but it's not perfect. And that's something we have to deal with in statistics. We don't have one exact right answer all the time. There's room for error, and we'll see that as we progress. We're going to represent this normal model with some unique notation. Because this model is symmetric, the mean and standard deviation are preferred for the center and spread. The mean is the center, so I can see, well, the mean here, the average is somewhere just below 75, and I could calculate the spread, the standard deviation, if I had the data. The mean is going to be represented by the Greek letter mu at this point. We've used X bar in the past. When we're talking about populations, we're going to use the Greek letter mu. It looks like a U with a tail in the front, a tail in the back. And the standard deviation is going to be represented by the Greek letter sigma. This is lowercase sigma. It looks like a cursive O with a tail on top instead of S. We're going to use this mu for mean, sigma for standard deviation when we're dealing with these normal models. And we can take it just one step further. If we know we have a normal distribution, which just about everything in Chapter 6 is, with some mean mu and some standard deviation sigma, the shorthand notation is this. We've got the capital N out front saying this is a normal distribution we're dealing with. It's not skewed left, it's not skewed right. There's one peak in the middle. The mean is the first number, and the standard deviation is the second number. They're separated by a comma. If we were talking about the height of men, which we did an example back in Chapter 3, we could use N parentheses 69, 3. The mean height for men was 69 with a standard deviation of 3. And that would represent our normal model with shorthand notation.